So with all these settings and requirements, how does ANPR get set up? Well, there is the guess method, where you install a camera at what looks to be a good position and walk up and down with a number plate and set the zone around where it looks clear. This is unprofessional and inefficient and inaccurate and does not always produce good results. Or simply use the relationship between actual object size, distance to object, focal length and object size on the sensor to calculate an accurate result to meet the client requirements. Sounds like a mouthful, but it's easy. The actual object size is known because government regulations stipulate a font height of 75 mm. This must occupy 25 pixels on the sensor. The optimum distance from an existing camera to the number plate can be calculated as long as the focal length is known. Alternatively, the correct camera spec can be calculated for a given site. This is the formula showing the ratio of object height on sensor to focal length is the same as the actual object height to the distance to the object. Following the simple example of a 1 megapixel camera with an 8 mm focal length and a 1/4 inch sensor, the far distance to a recognizable plate can be calculated by simply plugging in the numbers. Just a word on sensors, the quoted size is generally in inches and is indicative of the size of the sensor. Using a chart of popular CCTV size sensors to get the dimensions, a 1/4 inch sensor has a height of 2.4 mm and a 1 megapixel sensor has 720 rows of pixels. Then, manipulating the formula, the height of the required 25 pixels is 0.083 mm. Now, simply substituting the values into the formula, it can be seen that with these camera specs, a number plate can be recognized at up to 7.25 meters away from the camera. That is how the far distance can be calculated for an ANPR camera. This is why it is important to know the camera specs used when they are used for LPR functions. There is a chart attached with some common camera specs already calculated. When reading moving number plates, the required 30 and 50-degree angles need to be considered, as well as the frame rate. A few rules of thumb in this scenario would be: allow for at least 8 frames in the capture zone. The near point of the capture zone should not be closer than at least twice the mounted height of the camera above the number plate. The camera should be mounted as close as possible to view the number plate from the front. Looking at the moving example, if the camera is set to 15 frames per second, then 8 frames is about half a second. A car traveling at 60 kilometers an hour is the same as 17 meters per second, so half a second is about 9 meters traveled. If the camera is mounted at 5 meters above the number plate, then the close point must be at least 5 times 10, that is 10 meters away, and the far point 19 meters away from the camera. The diagram helps visualize the site setup. Note the distance is taken from the camera to the number plate and not the base of the mounting. The ratios can also be used to accurately estimate what the best specs are for a camera. Assuming there was a requirement to read number plates 17 meters away from a camera mounted on top of a 4-meter pole, what camera specs would be required? Let's assume that an upfront choice of a 2-megapixel camera with a 1/3 inch sensor was chosen, which would now require the estimation of the focal length. Firstly, from the sensor chart and known resolution, 1080 pixels covers 3.6 millimeters. Using simple Pythagoras right-angle theorem, the actual distance from the camera to the plate would be 17.5 meters. Remembering the plate must be 25 pixels high and the standard number plate font is 75 millimeters high, all the numbers can now be plugged into the formula, and the result calculated to be 19.5 millimeter focal length. So a 2-megapixel camera with a 1/3 inch sensor and a 19.5 millimeter focal length would meet the requirements. This is how the ANPR site can be set up to work each time with the minimum of effort.